Hello, I'm Mario Graf, and today I'm going to talk about text classification and machine learning approach. First, where am I? I live in Aguascalientes, which is in Mexico, and it's in the middle of Mexico. You are seeing a picture of the state, and I work at Infotech, and you are seeing the building of Infotech. We are a small research center that we are part of the uh, Mexican research centers. So let's move on. The outline of the presentation is first I'm going to talk about, I'm going to give an introduction, then talk about sentiment analysis. Um, One of the parts of sentiment analysis of or opinion mining is text classification, and the key ingredient in text classification is a text transformation, at least in the supervised learning approach. Then I'm going to describe an approach that we have developed, which is EBOMSA, and finally I'm going to end this presentation with the conclusions. Introduction. Can you tell me whether the sentence that you are looking at is it positive or is it negative? Well, it is written in Nahuatl and it is negative. It is negative because it says, "Hi friends, tomorrow I will not go with you to the bookstore." What about the next one? Is it positive or negative? It is in Spanish and it's easy for me, and it is negative, and it says, "A guard pander amid the loss of security control." With these two examples, you have an idea of what is text classification. Text classification is you wanted to classify documents into a fixed number of predefined categories. So in this problem has many tasks associated to it. One of them, for example, is sentiment analysis. We just saw two examples of sentiment analysis, and the idea is to classify the text into positive, negative, or neutral polarity. Or another one is emotion ordinary classification. Is you have a text and you have an emotion and you want to know the intensity of that emotion in the text. Or aggressive detection, toxic comment detection, related not to the text but to the author that produces the text, is author profiling. You want, for example, you are given a set of text and you want to know whether the author is a woman or a man, or what about the age of that person, or you are given a text in Spanish and you want to know whether the author was born or is from Argentina or is from Mexico, and so on. So this author profiling task is related to the author, and not to the and you use the text produced by the author to infer some of the characteristics of the author. But let's move on to sentiment analysis and opinion mining. I'm going to give some definitions of opinion mining and sentiment analysis. These definitions are not from myself. I take them from Bin Liu and Lin Sang. Opinion mining is the study of opinion appraisals, and you can read the rest of the sentence. So the idea, if you want to know the opinion of a person of a particular object, element, product, event, or even the opinion of a person about another individual. So, as you can imagine, this has many applications. One of them is in one of them is for the manufacture of a particular product. So, for instance, let us talk about mobile phones, and for example, Apple would like to know whether the screen is more important than another feature of the iPhone. So, in order to produce better screens than, I don't know, where the feature of a particular iPhone, or so. But imagine that you have many opinions. You have you have a forum where the users produce opinions. So in this case, it is not feasible for you to read all these opinions. So you wanted an automatic way to uh, distill to gather this information. So this is where the opinion mining and sentiment analysis field comes in. So you have a huge amount of information and you wanted to know all about this information about your products. So uh, the first thing is that, well, as you can imagine, opinion mining or the opinion of a particular person is most of the time is subjective, so it depends on the personality. For example, if you're a happy person, then everything, all the products, you will be more inclined to love it. So I'm just kidding, but I mean, it really depends on on your personality, how you're going to perceive a particular product or or object. And just to try to make this more clear, in the example I just produced, hi friends, tomorrow I will not go with you to the bookstore. It is positive. It is a positive example if the person dislike buying books. So if you don't like buying books, then not going to the bookstore, it is a positive fact. And it is negative if you want to buy a book and you want to go with your friends to buy a book. So that is negative. So it really depends on the person. So that's my point. One of kind of the aim of this opinion mining would be to kind of control the subjectivity of these opinions, but we are not. The, the research is not there yet. It is too complicated. So, but now that I have talked to you about subjectivity, let me try to explain a little bit more. An objective sentence is a sentence that presents some facts about an object. An example could be the phone broke in 2 weeks. I just bought a phone and it broke, and it is broken, and now. A subjective sentence, on the other hand, presents a personal feeling or belief. One example, it is a good day. It is good because I am here with you talking, presenting. But I'm talking about subjective here because sometimes it is confused that all subjective sentences are opinions, and this is not true. As you can see in the example, it is a good day. It is not an opinion because it is not. There is not an object there to have an opinion on. On the other hand, it is believed that the objective sentence doesn't contain an opinion, and this is also not true. Most of the time, objective sentence doesn't have opinions in it, but sometimes they do. And the example, the phone broke in 2 weeks, it is the phone broke in 2 weeks. It is it is it is an objective sentence that contains a negative opinion about the phone. Let me continue talking about opinions and the elements that composes an opinion. One of the elements that compose an opinion is the entity. An entity is the product that we're talking about, and each entity has associated attributes and a hierarchy of components, and where each component could also have attributes as well. So the other component of an opinion is the opinion sources, which is the person that is making the opinion. And just to try to write a little bit more about an entity and how does it look like, well, here is an example of an entity. And in this example, the entity is laptop. This is the entity, and it has associated the components, and the components, as you can see, it is a hierarchy. Well, it is a tree. These are the components, and each component is represented with this symbol. So you can see here is the component hardware, and hardware has components. One of these components is the battery, and the other component is the keyboard. And on the other hand, the entity, which is laptop, has attributes, and the attributes are represented with the symbol. The attributes are dimension, weight, and so on. Each component also has attributes associated to it. So for example, hardware has this attribute, which I didn't write it down, but operating system has this attribute, which is the type. Battery has the attribute, which is battery life, and so on. Try to put an example in this diagram. The example is this one. I bought a Mac. I have been an OS X user for several years and found it very intuitive. However, I dislike that OS X is moving away from its Unix root. The laptop is light and the battery lasts 4 hours, which is fantastic. So the entity in this case, which is the entity? MacBook. MacBook is the entity. There are different components that one of the components is, for example, this one, which is the operating system. The other component is the battery, and the attribute to the battery is the battery life, and so on. So you get the idea of how this is organized. As you can see, it's very complicated, and it is hard even for us trying to extract these categories in a hierarchy in the tree. So instead of writing down the tree and trying to look for the components and subcomponents and subcomponents and the attributes of these components, we will refer to all these components and attributes as an aspects. So instead of having a tree, we have just a list of different aspects, and then using this simplification, then an opinion is just is composed of 5 components, which one is the entity. An opinion could have many entities, so one is the entity. For each one of these entities, there will be plenty of various number of aspects related to this entity. Then it comes the opinion, the opinion orientation, which is positive, negative, or neutral. And but we could also talk about emotions here, or any other kind of category that we are interested on. The other one is the person that is making the opinion, which is the opinion source, opinion holder, and the time where the opinion was made. And this is an opinion has all these components. Some of them might be intrinsic to the opinion, or might be relevant, but and it could have more characteristics. This is just like a base definition, and like the starting point of an opinion, the starting point of a definition, the opinion's definition. So now we can depict all the process of opinion mining, which is you have a person represented as a cloud that it is making the opinion, and in this case, this person makes a positive opinion on time 1 for the second aspect of the entity tree. You have entity 1, you have entity 2, you have entity 1 has 2 aspects, which is this one and this one. Entity 3 has 3 aspects, which is this one. I followed the same notation, so you can kind of figure out what I'm talking about. And you can see also here that this person makes another opinion about opinion is negative, and it is also made in time 1 about the first aspect of entity 1, and this other person make also 2 opinions, one neutral opinion about this aspect and one positive opinion about this aspect. Okay, this is a way to depict the opinion mining process. And the example, let me complete the example in the example that I just described a few slides before. You can, with this idea, with these components of an opinion, then you can write down all these components into a table, or all these elements into a table, and then you can fill this table. In this opinion, for example, I bought a Mac, the entity is Mac, and so here is the MacBook, which is the entity, and then we need to figure out which are the aspects of this MacBook. One of the aspects is that the operating system, which is this one, and I like the operating system, so this is a positive opinion. Of course, I'm the one that making the opinion, and the time, it is not relevant here, so it is not available. However, I don't like another aspect, which is that OS, and it's very hard to find to figure out automatically, because I'm talking about the operating system, but I'm talking about the type of operating system, which is this another aspect, and it's kind of negative. And also there is another part of this one is another aspect, which is the battery life, and it's positive. It is positive. As you can see, it is not an easy task to fill this table, to automatically fill this table, and the process, or the objective of opinion mining is, so you are given a document or a set of documents, and the process is to find all the opinions that are in the documents, or in the set of documents. In order to find all the opinions, what you need to do is you need to follow 4 tasks, or you need to perform 4 tasks, which one is entity extraction. You need to know which are the entities. You need to know which are the aspects of those entities, then identify who is making the opinion. In some cases this is very easy, because it is already in the metadata of the web page, or in the it is easy sometimes. The time and the opinion source sometimes is easy to find, because it's already there. And finally, for each one of the opinions, you need to know the opinion orientation. So you need to identify whether the opinion is positive, negative, or neutral, or any other label that you want to assign, or any other category that you wanted to assign. Well, I just talked to you about sentiment analysis and opinion mining, and well, there are plenty of research topics in this area. One of them is kind of a simplification of opinion mining. So you wanted to know only the sentiment of a particular document, and this is the case that we are dealing with later on in this talk. So in this problem, in document level sentiment, what you wanted to find, what you are dealing with is, you are assuming that a document contains only one opinion, and that opinion is relevant, or beforehand, which is the aspect and the entity of that opinion. And also you know the person who made the opinion, and the time it might be not relevant, but you also know the time. So you are only interested in the document contains only one opinion, and you are only interested in knowing whether that opinion is positive, negative, or neutral, or any other category. Related to this topic is sentence subjectivity. So you are given a sentence, and you wanted to know whether the sentence is subjective or not. And if the sentence is subjective and it contains an opinion, well, you continue and with the process, and you want to know whether that opinion is positive or negative. And opinion in objective sentence is, first you need to know if the sentence is objective, and if it is objective, then you want to know if the sentence contains an opinion, and finally, if the sentence is an opinion, then you want to know the polarity of that sentence. Now, using all the description of an opinion, it comes aspect-based sentiment analysis, which is well, you have all the components of an opinion, so you need to know, first you need to extract the aspects, and then once you have the aspects, you will classify the sentiments of those aspects. So it's kind of the complete task without any simplification. We have only talked about opinions that are expressed in text. For example, this is a good mobile phone, so it is good, the opinion is positive. But sometimes you don't express an opinion on terms by the product, but you produce an opinion comparing one product to another, and so you say this product is better than the other. So another related topic is retrieve all those opinions that are in comparative terms. A product is better than B. That is another research topic in this field. Also, it is related also to other natural language processing task, which is entity recognition. Sometimes opinion source, sometimes extractions is already there, but the entities are sometimes difficult to find because because this is an informal way of writing. So there are a lot of nicknames for a particular product, and you need to infer which nicknames refer to the same product. So entity recognition implies grouping the products with different names that are referring to a particular one. And lately we are online most of the time. I'm buying a lot of things online. So lately there is another problem, which is opinion spam detection. You want to know which opinions are real and which ones are fake. And this is also very related to fake news or any other. This is related also to fake news detection. And so you get the idea why the reasons that you need to identify those opinions that are real from those that are fake. And you already have an idea why the people start making fake opinions. Of course, they are being paid by a particular product or a particular component, so that the one product will be better perceived by the audience. Well, I have described opinion mining as in general terms, and I'm going to talk more about text classification. As you can see, text classification is one of the components of opinion mining and sentiment analysis. And the approach that I'm going to talk about is a supervised learning approach. In supervised learning, you start with a training set. So a training set in this context is nothing, is like this one. So you have a text, and associated to that text you have a label. This case is neutral. You have another text, and you have associated another label, positive, and you have another text, and associated to this other text you have a label which is negative. Of course, you have more than 3 texts, so this is to indicate that you have, just to put a number, 1,000 of different texts, and each one has a label associated to it. So the approach is very simple. Imagine that you can represent a text into that you can transform a text into a vector. So if you have a vector, then you can put it into a vector space. Well, it is a vector space, and imagine that we have only a plane. So if we can represent a text into a 2 dimensions, then we can write it into a plane. And so the idea is that this dot represents a text, this dot, and each of these dots represents a text, and the color of the text represents the label. the previous example has 3 labels, but imagine we only have 2 labels. So the blue dots are positive and the orange ones are negative. So in these conditions, then it is very simple to solve this problem. You only need to find a line that splits the positive examples versus the negative examples, the positive points. So this is the positive point, and which is a positive text, and this is a negative text. And given that you have a line, if you have another point here, then you know that this point is positive, and if you have another point here, you know that this other point is negative. And it is straightforward to represent this or to solve this. So each text is in a 2-dimensional space, but you can say here that it's in a d dimensions. The orange are represented with -1, and the blue dots are represented with +1. And the classifier is in the previous example is just a line, a plane in a d-dimensional space, and the class is given by the sign of this function, and so you need to compute the coefficients, to identify the coefficients alpha I and alpha 0, so that most of the examples are correct classified. So the problem is not how to solve. Once you have the text into a vector space, then the problem is kind of easy. You can use a traditional classifier to solve this problem. I only explained a linear one. So the key component is a text transformation, which is the function that transforms the text into a vector, in general into a d-dimensional vector. One of the simplest text transformation is the back-of-words model. The back-of-word model starts with a dictionary where each component is where each word in the dictionary, part of the word of the dictionary, is a dimension. Just to try to write down an example, a back-of-word model starts with a corpus. In this corpus, you find out all the different words, and with the different words, you write a table where each different word is the header of the table. So you can see here is Carly, and here is to indicate that there are more words than the ones that we are seeing. And now that we have defined the header of the table, each sentence in this corpus can be represented in this table only indicating whether the particular word appear in the sentence. So you can see Carly appears, so assign 1 here. Fiorine appears, so assign 1 here, and so on. And you see here that Chris doesn't appear in the first sentence, and as you can imagine, it doesn't appear. What about the last one? You can see like here, fields here, like here, and there is no other word that appears here. Well, at least not the one that we are seeing. Now, as you can imagine, if we look at this row and this row, and we keep the header fixed, then 1, 1, 1, and blah blah 0, it's a vector, and it is a really long vector, but it is a vector, and each of the components has a meaning. So the first component, if it's 1, it means that in that sentence appear Carly's. As you can see, that there are many problems in this representation. One of them is that you lost the order of the words, but there will be more problems. But it's very efficient and it is simple to implement. But I'm not going to talk about back-of-word models. I'm going to talk about another text representation. Imagine that you have a function. Not going to talk a lot about how to build this function, but you have a function m that receives a text and it transforms into a 64 dimensions, where each dimension represents an emoji, and the value of the dimension tells you kind of the probability, not necessarily the probability, but it is easier to explain if we think it in a probability, that particular emoji will be associated to that word. So let me put an example. Good morning in good morning, the most probable emoji is this one, and the second most probable is this one. In I love that song, the most probable emoji is this one. But it is not important to know which which is the most probable emoji. It is important to know kind of the probability of all these emojis. So in order to I would like to make a live presentation to try to explain this a little bit more, because it's interesting, and I'm going to use one of the developments that I'm going to talk about, which is Evomsa, and as you can see, I'm in CodeLab, and in Evomsa we have implemented this model, this text model, text transformation, and we call it, and it is in different languages, as you can imagine, and we are going to use the one in English. Okay, so well, the first part, I installed Evomsa. This one I only loaded some of the libraries and loaded the model, and so let us try to imagine the text. It is Monday, and so we transform the text into the vector space, and as you can see, well, it's a matrix, because this has been implemented to receive a list of text, not only one text. So it is a matrix, but as you can see, well, it's very, as you can see, I'm going to put the shape of this. There, it contains one text and in a 64 dimensional, and each one of the values. Okay, let me talk a little bit about how this model was built. It was built using a back of Word models, and the classes or the labels of the labels were the emojis that appear in a particular text. So the emojis are removed from the text and they are used as labels. And as the classifier was a support vector machine, and the positive was +1 and negative indicates that that particular emoji doesn't appear. So the vector is not probabilities, but you can see that if the number is positive, it kind of tells you that that particular emoji is kind of related to the text given. So for instance, this one. And okay, I'm going to write down which are the emojis. Okay, this doesn't look good. Okay, I'm going to write which are the order of the emojis. So for instance, this is the kind of sad face, and so this value corresponds to this face. Okay, now you get the idea. You have a text, and then you supply this text to a text transformation. The text transformation returns a 64 dimension, and just to complete the example, I'm going to find from all these numbers which is the maximum number, and given that we know the labels, I'm going to write down the three most related emojis to the text, which is it's Monday. Okay, it's Monday, and the most related is that I'm sleepy. I could use another one. It is Friday. It is Friday, and going to do the same thing, and so I'm happy on Friday. That's the point. Okay, moving on. What about how can we use these models? Okay, the back of our models and the emoji space. How can we use it to solve the problem of text classification? Well, the idea that I'm going to present is called Evomsa, and the idea is you can have many representations of text, and so once you have many representations of text, what you wanted to know is kind of combine all these representations to make a final prediction, and that's the idea behind EBOMSA. So you have a text and you have many representation. You have this text, and this one is one representation, this one is another representation. This particularly, this is the representation of emoji. This representation comes from fast text, but let me try to write it down. The first representation is just a back of core model trained with the training set. The other representation is just label data set sentiment analysis, but which is not related to the training set. It's a data set that another person just kind of a general data set that is labeled with positive, negative, and neutral opinions, but it is not specific to the training set. Thumbs up and thumbs down, it's a lexicon-based classifier, so you count the number of positive words and you count the number of negative words, and you just keep output those counts. So the number of dimension of this thumbs up is 2. The number of dimension of back of core models is more than 10,000 words, more than 10,000 dimensions. And emoji space, we talk about it. So it has a 64 dimension, and fast text we used the 300 dimension representation. So how can we combine all these representations? How can we combine these representations? Well, the naive approach is just concatenate all the vectors and then. But let me talk about this naive approach. Suppose we use a linear classifier. So if we use a linear classifier, then BAMs and the human annotated have the majority of coefficients because they have more than 10,000 coefficients. Fast text, on the other hand, has kind of 300 coefficients, and emoji space and thumbs up really are unrepresented because they only have 66 coefficients. So what the linear classifier is going to do is that it only going to listen to BAMs and human annotated, and the other 3 representations are useless. So what is the alternative approach? Well, the alternative approach is try to make all these representations, to transform all these representations into having an equal number of dimensions. One way to do that, of course, you can use, for instance, principal component analysis or another technique to reduce the dimensions. But another approach is, and the approach that we follow is, I didn't mention, but this work has been published in the IEEE Computer Intelligence magazine. Another approach is use stack generalization, which is an old technique, and the general idea is to use the inputs, to use as the inputs the outputs of different text classifiers. So you have different text representations. So instead of using the text representations, you can use the labels to produce a text classifier for each one of the text representations. So the idea in the emoji space, so you have the text representation, which is this function m that transforms the text into a 64-dimensional space. But what about if you have a classifier h that receives this 64 and returns the decision function, which is, let us imagine that we are dealing with 3 classes, then it's a 3-dimensional vector, RL, where L is the number of labels. So if we follow this, if we train H using the training set, then the representation of the emoji space, is the composition of these 2 functions, and the representation will be in 3 dimensions. So using this, we are dealing with the diversity of dimension in each text representation, and so each text representation combined with a classifier produces the same number of components. One note is that the training set cannot the training set cannot be used twice. So in order to do this, in order to apply stack generalization, there are two paths. One is following a K-fold strategy, or you can split the original training set into two. The first one is to train H, and the second one is to train the stack classifier. So the stack classifier, okay, let me try to explain this into the diagram. So here you receive the text, but here is a classifier. I'm going to write it with C, and then it produces an output. So here D is, for example, if you have 3 classes, here D is 3. Again, here comes the text in BAMS in this module, and instead of using the output of this text representation, here you use a classifier, and the output of the decision function of this classifier, it outputs here, and you do the same here. So, and these outputs are concatenated, and these form the vector space. Once you are in this space kind of has all the opinions of the different text models. You apply a classifier. In this case, we apply the BODAG, and then we predict the final class. I'm not going to talk a lot about the BODAG. BODAG is a classifier based on generic programming, and just to depict the idea of what it's doing, the BODAG produces a nonlinear model. Here we are seeing an example where the inputs are in red. These are the inputs. And the output of this classifier is in green. This is the output. Okay, now I'm reaching to the conclusions. This approach of combining different text representations, well, we have tested on several competitions. I didn't produce any of the results, but let me talk about the conclusions. Well, I talked to you about sentiment analysis, talked to you about text classification, briefly. Most of the time talk about opinion mining, and then a little bit about text representation and emojis and the emoji. Describe a little bit about one approach that we have been following for text classification, which is EBOMSA. And well, I started with 2 examples in 2 languages, and this is to try to tell you that EBOMSA is multilingual and multi-domain, because we didn't it can be applied to almost any language, and the idea is that it can be easily add new knowledge, or in the sense that you can add new text representations. We have tested on several sentiment analysis competitions, and at the time we wrote the journal paper. If we compare the EBOMSA on different competitions, and it is in the first places on 5 of those competitions. Of course, this was done after the competition ended, so it is not kind of fair, but we did compete with EBOMSA on CEMEVAL 2018, and obtained 2nd place in Spanish and 3rd place in Arabic, which is a good news about this approach. Okay, well, if you have any question or comment, please send me to the email, and I will be happy to reply. Have an excellent day.